Hello everyone, in this video I'll be sharing you about covalent character of ionic bond. When we say about ionic bond, there is positive and negative. Let us say the example of sodium chloride, positive and negative. So all ionic bonds carries a positive and negative. So positive means cation and negative means anion. To know it, we have just represented by minus the anion and cation plus. And cations are generally smaller size than that of the anion. So when this cation and anions are brought closer to each other, there will be some attractive force between them. So this cation will try to attract the electrons of the anion. Okay, this cation will try to attract the electrons of the anion. And due to this attraction, the size of the anion or the electron cloud of the anion, because electrons are present in a particular area, so electron clouds of the anion will be somewhat shifted towards that of the cation because of the attractive force of the cation towards the anion. So in this way, the size of the anion or the shape of the anions will be somewhat deformed. So it is showing here, so deformed, and the electrons are concentrated more towards these two nuclei than this area. So electrons are pulling this side by the cation, so electron will be concentrated more here, and in this way some pole arises here, so electron density is more here, so minus, partial minus, and electron density is less here, so partial plus. So in this way there is somewhat shearing, that it's behaving like shearing of electrons between these two nuclei, and we know that when it is shearing of electrons, we call it as covalent bond or covalent character. So there is some partial character of covalent here present here. So that is covalent character of ionic bond. That means there is some partial character of covalent in the ionic bond also. So remember that no bond is 100% covalent, or no bond is 100% ionic. Some percent of ionic part are present in the covalent bond, whereas some percent of covalent character are present in the ionic bond. Okay. So when cations or anions are brought closer to each other, because of the attractive force between these two, the shape or the geometry or the shape of the electron cloud will be somewhat distorted towards that of the cation, and also the cation will also distort, but this, due to small size, it is not much of pronounced. Okay, so in this way there will be mutual shearing, there will be shearing of electron between these two nuclei, so it behaves like a covalent character here. So covalent character of the ionic bond. Now let us know about the how much it distort, what is the capacity of the cation to distort. Let us learn about it. So when we talk about the cation due to its charge, okay, positive charge, okay, so it will have the capacity or the ability to distort the or to change the shape of the anion or the electron cloud. So this ability of the cation to polarize or deform the electron cloud of the anion is called polarizing power of the cation. So power is to whom? To whose it belongs? It belongs to cation. The ability of the cation to polarize, okay, to change the electron cloud of the anion is called the polarizing power of the cation. And also the anion, due to the presence of the cation, will have the tendency to change itself. So it is what called the tendency of an anion to get deformed or distorted or polarized by the presence of the cation is called polarizability. Polarizability is used for the terms of the anion, and polarizing power is used for the terms of the cation, because the cation has the power to deform the shape or the electron cloud of the anion. And the process itself, where the cation polarized it, where the anion get polarized, that this process is called what? Polarization. Okay, so when we talk about polarization, how much extent does it get polarized? So we have to know it. Okay, so more the polarization, more is the covalent character. So if the polarization is more, then more will be the covalent character. So in order to know the extent, how much the extent of polarization, and on the polarizing power of the depends on what? Depends the extent, how much extent that is get polarized will depend on the polarizing power of the cation and polarizability of the anion, and this will study in the Fajan's rule. We'll study in Fajan's rule. Okay, so Fajan's rule says that the cation with the smaller size, will have high polarizing power, because why? See, when the cation is, see, lithium, sodium, potassium belongs to group 1, and lithium has the smallest size here. The smaller size of the cation, more is the polarizability. More the polarizability, more is the covalent character. Okay, so more is the covalent character. Because size of the cation is small, see, this nucleus is having more effective, because the size of the cation is small, the distance is very less, so the nucleus is very much effective. So smaller the size of the cation, more is the polarizability of the cation, more is the polarizing power of the cation, and more is the covalent character. Okay. So in the second point, the anion with the larger size, will have high polarizing power. The anions with the larger size will have high polarizing power. So among these two, chloride and bromide, let's see here, bromide is having larger size. So larger size means what? If it is having larger size, that means the nucleus is not able to attract the electrons properly. It is with a great strength. So the cation can easily attract or pull out the electrons of the anion. So the anion with the larger size have high polarizability. So that is why among this NaCl and Br, who is more polarized, NaBr is more polarized. So we'll have those which is having more polarization, more is the covalent character. And for effective polarization, it also depends on the charge density. So more the charge density of the cation or more the charge density of the anion, more is the polarization. NaCl, all the anions are similar, but cations are different here, because the cation has plus. Here in this case it has 2 plus. So high charge density is what? In the aluminum 3 plus. So aluminum Al3 plus will have high polarization, so more covalent character here. Okay, so in case of anion O2 minus, F minus, who is having more charge density here? So more charge density of the anion is having here in the 2 minus. So more the anion charge, more is the greater will be the size. So greater is the size, the nucleus will not hold the electrons properly tightly. Okay, so if the size is greater, the nucleus cannot hold the last valence electrons properly. So that means any cation can attract these electrons easily. So in this way, so more the charge density of the cation or anion, more is the polarization. More is the covalent character. And then last, cation with the pseudo inert gas configuration. Pseudo inert gas means having 18 electrons, have high polarizing power, will have high polarizing power than that of the noble gas. So among sodium plus and copper 2 plus is having pseudo noble gas configuration, and this will have more polarization, and more polarization means more covalent character. So applications of polarization, so more polarization, more is the covalent character, less is the solubility in the polar solvent. Okay, because water is the solvent, polar solvent, so it should be since the covalent character is more, less will be the solubility. More polarization, more covalent character, less is the melting point. Let us solve some questions here. Okay, which is already done. So lithium, all these metals are same, so cation are all same. So which is same? As it is, let us consider the anion, which is having larger size. Anion should have always larger size to get polarized easily. So anion is having, this is the larger size, so this will have more covalent character, more polarization, so more is the covalent character. Again, let us take about lithium, sodium, potassium and rubidium. So among this case, lithium, all the anions are similar. Let us consider the cation here. In case of cation, the size should be very small, so smaller the size, more is the polarization. So this will have the more polarizing power of the cation, so more is the covalent character. Cu, Na, this is having pseudo configuration, and pseudo has more polarization. This will have more covalent character. Among this 3, fluoride, oxygen, the charge of the anion here is N3. N has the more charge, so this will have more polarization. So more polarization, more is the covalent character. So among this anion, N is having more charge.